Now, these things hanging out the side, these are capacitors. These are high voltage ceramic disc capacitors. These are rated at 20,000 volts, 20 kVs. And again, we need about 7 kVs to initiate a spark. These are called peaking caps. I have a little grounding stud right here I'm going to clip onto so that this and this are now electrically connected, which means that this and the outer portion of the spark plug are electrically connected. What these peaking caps are going to effectively do is put capacitance in parallel with the spark plug. And as the coil discharges the energy, it's building up a voltage which creates a push, a voltage push to try to jump that air gap. But as it dumps that energy, the capacitor is going to absorb equal amounts of it. Now, the ignition coil is an inductor. And compared to a capacitor, the inductor charges and discharges extremely slowly. Where the capacitor comes in there, and it can charge up, I'm done, and then it discharge, I'm done. So let's watch and see what that actually means, right? We're going to start out with a small 150 picofarad capacitor. Let's, yeah, that ought to do it. All right, here we go. Ready? Can you see a difference? Now, that was 150. Let's try a 330 picofarad. If you look at it from this angle, this one, you can kind of see the light. This one's literally throwing the flame outward. No, now it's just see the light. Whoa, now it's jumping and bulging.
Oh yeah, it's dancing already.
Well, if a little is good, a lot must be better. Well, up to a point. Let's try a 480 picofarad. I think we can arc weld with that almost.
Yeah, that's not going to melt stuff.
The rules of capacitance are if we put two in parallel, you add the two. So if we take, let's see here, 480 plus 330, 5, 10, 810 picofarads. Whoa, baby! 810, 960. 960 picofarads coming at you here very shortly. Questions, comments, or observations?
At what point do you melt your electrode thingies?
I'm currently running 150 picofarads on the Jeep. I wanted to get some time under the belt with them and then pull the plugs and check them. But the point that you're making is leading up to, it can run great for about a week and then you're back to misfiring because you just killed the plug.
Okay.
So that is a legitimate concern. Although we could do this really awesome display here, and show an incredible spark. And oh man, you will feel it. You do this on the vehicle and you can feel that plasma discharge while it lasts. So the delicate balance is just how powerful can you make it and still get reasonable longevity out of the spark plugs. Now, this is the aquapulsar unit. This is a plasma discharge ignition controller here, and it's burned out, which is why we're not going to actually look at it today. It's not that much more intense than what you just saw. It is, but not that much more intense visually. And I had run the aquapulsar where I started out with just I think NGK non-resistor spark plugs. And then it was just killing the electrodes, arc welding, like killing the electrodes, eating them up. And then I went to brisk non-resistor. And again, it kind of ate up the electrodes. And then I went to the plugs that we just looked at, the aircraft plugs. There's no electrodes on the outside to eat up. Ha ha! I conquered that one, so I thought. And it took a while. It actually lasted over 6,000 miles. But then I started getting a misfire again. What the heck? So I pulled the plugs, and what I found is that the spark energy was so intense that it burned through the ceramic. And the spark was shorting out back here. It was never even getting to this point. It was shorting out back here. So you can get such an intense spark that you can't keep spark plugs in. Not with the technology available to us today.
That's my next question is anybody going to come up with something that will work?
Robert Krupa, he spent his life working with Champion spark plugs. That was his career. And then he retired. And the whole time he was with Champion, he was like, why don't you guys actually make real quality spark plugs? Well, because they're consumables. And real quality spark plugs, you only sell once. But Bob Krupa came up with a design that was multifaceted. He had a ball-shaped center electrode. And then he had a cage that went around for the outer electrode. The electrodes themselves were made of a beryllium alloy, which is incredibly durable. I mean, you're up there with iridium or better as far as how long will they last. But then also the ceramic was different. The ceramic on all but two of these plugs are made of the same material. So it doesn't matter if Champion or Autolite or Brisk makes the plug, the ceramic is the same material. These two plugs, which we haven't looked at yet and we're going to here next, are made by a company called Polestar. Polestar spark plugs take the peaking cap and it's built right into the spark plug. So to test the Polestar plugs, the Polestar plugs use an aluminum oxide ceramic, which is way more durable than what the rest of the spark plug companies are using. I do believe Bob Krupa used aluminum oxide type ceramic in his. He was starting out with what's called billet. So it's just a long tube of ceramic, and then you have to cut it to length, then you have to bore it out and actually, kind of mill it into the shape that it needs to be to work in the spark plug. Polestar, I'm not sure how they do it. Theirs are smooth where the rest of these are ribbed, so they may actually use a billet type of ceramic as well. But the Polestar plugs create a capacitor effect. And if you don't know much about electronics, the way a capacitor works is you have a conductive plate, and then an insulator in between. The closer those plates get, the higher the capacitance, but the lower the voltage rating. So if you want to increase the voltage rating, you increase the insulation value of your insulator. So if you have a weak insulator and the plates get too close, it'll burn through. So a higher insulation value separator, now you can move them closer together and get higher capacitance. And then the other way to increase capacitance is use bigger plates, more surface area close together. The way the Pulsar plug works is you have the part that goes down the center that the ignition wire clips onto, and then that conductively goes down the center and comes out at the center electrode. So that conductive path, Pulsar gets real close to the metal hex on the outside. So you have conductor in the middle, conductor on the outside, and then the ceramic itself becomes that insulator in between. Boom, you have a built-in capacitor. But in order to do that, that ceramic becomes extremely thin. Early Pulsar plugs, if you went boom, they would crack. They were very, very fragile. They were using the same ceramic as everybody else. They totally revamped the machining and whatnot, and they used this more durable ceramic so you can stick your tongue out at it even and it won't crack. So let's compare the Autolite iridium with the Pulsar iridium, and let's see if we can see any difference here. Remember, the Pulsar has a built-in capacitor, right? Observations.
The Pulsar may have been a tiny bit brighter, but I didn't see much from this angle.
I agree. The Pulsar seemed to have seemed to have a little more power than the Pulsar, but still wasn't as consistent as the basic iridium.
All right. When I first put this together, I did that test and I went, uh-oh. I've been promoting Pulsars and look at that. It's no brighter than a regular iridium. So I got on the phone to Lou. Lou's the guy that owns Pulsar. Said, Lou, I am concerned. And he said, well, I want you to think about something. What are the electrodes made of on both plugs? I said, iridium. He said, what is the medium you're trying to fire them in? I said, open air. He said, okay, so iridium electrode, the coil's going to build up until it has just enough energy to bridge that gap. Are you with me so far? I said, yeah. He said, what is that? Well, about 1500 volts. He goes, so how much energy are you storing in the capacitor with 1500 volts? So, well, I guess not a lot compared to, higher outputs. I said, okay, good, you're following me. Now let me ask you this. What happens in the combustion chamber? Are you going to fire at 1500 volts? Or are you going to have higher pressures that are going to fight that and jack that output voltage higher, that threshold to jump the arc higher? Oh, I see where you're going with this. What's going to happen with the Autolite iridium is what you see here is what you're going to get in an engine. It's not going to change. If we had iridium on these guys and I was playing around with the peaking caps, it wouldn't really change. Maybe a little bit, but in open air, it's kind of limited by the material. Especially with iridium or platinum.